so last time we figured out how to find the distance between two vectors, and it doesn't matter what dimension we're in. This could be an Rn. Okay, so let's look at an example. We're just going to do R2 just because I can draw it, but this will work for all dimensions. All right, example. So let's say we have the vector u, which is 2, 1, and the vector v, which is 0, negative 1. And we want to find the distance between these two vectors. Okay, so remember the distance is the norm of the difference of our vectors. And it actually doesn't matter which one we do first since we're finding the norm. It's always going to give us a positive number. All right, so let's go ahead and subtract these two. So 2, and then, subtraction, 2. Let me just rewrite this. 2 and 2. So we just need to find the norm of the vector 2, 2. Well, that is the square root of 2 squared plus 2 squared, which is the square root of 8. So the distance between these two vectors is the square root of 8. I'll go ahead and draw these two just so we have a little picture. All right, this should be all I need. All right, I'm going to use a different color here. All right, so my u is 2, 1. My v is 0, negative 1. And so then we have the distance between the two. That's going to be this vector. Doesn't matter the direction. This has length, square root of 8. Okay, so the very last thing we're going to talk about in this section are orthogonal vectors and what it means for two vectors to be orthogonal. All right, so I'm going to draw a picture and kind of floating in space, but let's say we have like an axis. It doesn't really matter here, but let's say that this is our vector u. And then this is our vector v. These two are perpendicular to each other, right? We got a right angle right here. All right, in between them, we got the 0 vector. And if we go the same distance in the opposite direction, we're going to have negative v. All right. So if I draw a vector between the tips of u and v, this is our vector u minus v, which we discussed before. And then if I draw a line between u and negative v, this is the vector u minus negative v, which is u plus v. So if we have perpendicular vectors, that means u minus v is going to be the same as, or the length of u minus v is going to be the same as the length of u plus v. And that's where we're going to get our definition for orthogonality. All right, so the two lines that I drew here, they're perpendicular. but let's talk through it. All right, so these two lines are perpendicular if and only if the distance between u and v, or u minus v, is the same as the distance between u plus v. If these are equal, then our lines are perpendicular. So let's actually do the math and see what this looks like. So what does it mean to find the norm of u minus v? Well, that means that we need to take the square root of u minus v, dot product with itself. Same on the other side, the norm of u plus v, that is going to be the square root of u plus v, dot product with itself. Okay. So that's straight from the definition of the norm. All right, notice I have a square root on both sides. Don't need it anymore. Okay, let's actually work this all out. Okay, so if we're going to do u minus v dot product with u minus v, we're going to kind of like FOIL it all out. So we're going to have u dot u, then we're going to do minus 2 of u dot v plus v dot v. So we just fold it out using the dot product. We're going to do the same on the right side. All right, so notice we got some same things on both sides. We got u dot u on both sides, those can cancel, v dot v on both sides, so we're going to have negative 2 u dot v equals 2 u dot v. Okay. I'm going to move everything to the right side so that we have 0 equals 4 u dot v. Divide the 4 back over, 0 equals u dot v. So what does this tell us? That our two lines that we have are going to be perpendicular if and only if the dot product between u and v is 0. And that's the definition of an orthogonal set of vectors. So, definition. Two vectors, u and v, in Rn are orthogonal if u dot v is 0. That is the definition of orthogonal, and so we'll use this for the rest of class. All right, I'm going to continue on with 2 more examples and then we'll be done with this section. So example 1, let's say we had the vector u, which is 2, 1, and v, which is 0, negative 1. Are these two vectors orthogonal? Well, let us find the dot product. So the dot product between these are going to be 0 and minus 1. That does not equal 0. Therefore, U and V are not orthogonal. So for us, orthogonal is like perpendicular but in a higher dimension. All right, last example. Let's say we have U in R3, so it's 1, 2, 1. And V, also in R3, 3, 1, negative 5. Are these two vectors orthogonal? All right, well, let's find U dot V and find out. All right, dot product, we got 3 plus 2 minus 5, which is 0, which means these two vectors, U and V, are orthogonal. All right, that's the end of the section.